Welcome to a new deep dive. Today we're taking a bit of a shortcut into database technology, specifically the latest from MongoDB. We've got some really interesting sources here about MongoDB 8.0 and how they've made some, well, pretty significant changes to replication. So our mission today is really to unpack what's different, what's changed under the hood, and why it's actually a big deal if you're running, high traffic applications.
Absolutely. And what's really fascinating, I think, is digging into why replication is so fundamental in the first place. I mean, think about e-commerce sites during massive sales or financial platforms where every millisecond counts. Any busy app, really, where the data consistency, data availability, it's not just nice to have, it's absolutely critical, right?
Yep.
So yeah, this deep dive, it'll show you how MongoDB tackled a really tough, long-standing challenge, making sure your systems can actually keep up.
Okay, so let's get into that challenge then. What exactly was MongoDB facing with the older versions? You mentioned replication used a sequential model. What does that mean exactly?
Yeah, sequential. So essentially, reading the Oplog entries, that's MongoDB's log of all the database operations, right? It's ordered, immutable. Reading those entries and then applying them to the secondary databases. That all happened one after the other in a single line, basically.
Okay, that sounds orderly, maybe even simple, but I guess the simplicity was the problem.
Exactly. It sounds neat, but when the system gets hammered with traffic, that single line just backs up. Under heavy load, this sequential thing caused, well, serious replication lag. Performance on the secondary nodes really suffered. Imagine that flash sale again. The secondaries, they just couldn't keep pace with the primary server.
Okay. And that lag, it wouldn't just mean slow dashboards, would it?
Oh no, much worse. It hits your analytics, yeah, but also backups become inconsistent or delayed.
Yeah.
And crucially, think about failover. If your primary node goes down unexpectedly,
Your secondary isn't up to date enough to take over quickly.
precisely, failover times could blow out. So the big question became, how do you keep everything synchronized at scale? Without the whole system grinding to a halt.
Right. That paints a much clearer picture. I can feel the stress just thinking about it, waiting for that secondary to catch up during an outage. Yikes. So MongoDB 8.0, what was the big engineering leap? How did they solve this bottleneck? What's the breakthrough?
The breakthrough was moving to a parallel replication model. It really is game-changing for them. So instead of that single file line, that one after the other approach, MongoDB 8.0 uses separate threads, a writer thread and an applier thread.
Okay, separate threads. How does that work in practice?
Well, the writer thread's job is just to read the Oplog entries coming from the primary. It reads them efficiently and then writes them into a local buffer on the secondary. Meanwhile, kind of independently, the applier thread picks up those entries from that buffer and applies them to the actual secondary database.
Separating the reading and network part from the actual database write part.
Exactly. It's a separation of concerns, allows them to happen much more concurrently.
That makes sense. It's a pattern you see in lots of high-performance systems. But database consistency is paramount, right? How did they ensure that splitting these tasks didn't introduce, new problems like synchronization issues or locking contention that might just cancel out the performance gains? And does this new setup give us more insight into what's happening?
Yeah, that's the critical piece, and where the design is quite clever. This architecture, it drastically cuts down the lag and boosts the throughput, specifically because these processes can run side by side, more or less. But it's not just throwing threads at it. They also introduced a dual buffer system. This is key.
Dual buffer. Okay, tell me more.
So you now have two distinct buffers involved in the process on the secondary. There's a dedicated write buffer. That's where the entries land first, straight from the primary, via the writer thread. And then there's a separate apply buffer. This holds the entries just before the applier thread actually writes them to the database.
Okay, write buffer, apply buffer, 2 stages.
Right. And this architectural shift, it does provide much, much better visibility into the pipeline without messing up the consistency guarantees.
That sounds really useful, that dual buffer system. It seems like it gives you a much clearer window into the replication pipeline itself, which for DBAs, that kind of insight is gold, isn't it? So that brings us to monitoring. How do they change the monitoring tools to match this new architecture? Because the old metric, metrics.repl.buffer.count, that's gone now, right?
Deprecated.
Deprecated, yeah. It just doesn't cut it anymore. It couldn't tell you where the delay was, just that there was a delay somewhere in the buffer. So MongoDB 8.0 gives you new, much more specific metrics. They're split explicitly for the write side and the apply side. You're looking at things like metrics.repl.buffer.write for the write buffer and metrics.repl.buffer.apply for the apply buffer.
So you can see the size or count for each buffer individually.
Exactly. It gives you finer-grained observability. It helps DBAs pinpoint bottlenecks much more accurately. For instance, if you see that write buffer growing really large.
Right. That often points towards network issues getting data to the secondary, or maybe I/O contention just writing to that initial buffer. It's an input problem usually.
Yeah.
But if you see the apply buffer growing large while the write buffer is maybe normal,
Then the problem is likely on the secondary itself trying to apply the changes?
precisely. That's a strong signal of CPU bottlenecks or disk I/O problems on the secondary during the actual database writes. The applier thread can't keep up. And knowing which buffer is the problem, that's invaluable. It tells you where to focus your optimization efforts.
Wow. Okay. That level of diagnostic detail sounds incredibly powerful. Much better than just knowing the buffer is full. But thinking about DBAs who've maybe relied on that simpler single metric for years, is there a bit of a learning curve? Are there any common, pitfalls to watch out for when people start looking at these new write and apply buffer metrics?
That's a really good point. Yes, the insights are way better, but there's definitely an adjustment period. I think the biggest pitfall is just carrying over old assumptions. Trying to map old alert thresholds directly onto these new metrics won't work well. They signify different things. So action item number 1 is definitely update your monitoring dashboards. You need widgets for both write and apply buffer metrics. And you absolutely need to adjust your alert thresholds. What was bad for the old combined buffer might be normal for one part and critical for another now.
Right. Need to establish new baseline.
Exactly. And then think about your runbooks. You know, those step-by-step guides for handling issues. Any procedures that mention checking metrics.repl.buffer.count, they need revising. They need to point to the new metrics and guide the team on how to interpret them.
Okay, so update dashboards, adjust alerts, revise runbooks.
And critically, educate the team. Make sure everyone who might troubleshoot replication understands this new structure, understands what a full write buffer means versus a full apply buffer. Being proactive about adopting and understanding this, it can save a ton of headaches down the line, especially during an actual performance issue.
Makes sense. So wrapping this up then, ultimately these changes in MongoDB 8.0, they seem to enable much faster replication.
Definitely faster.
And also provide vastly better, more precise monitoring tools. It feels like a really significant step for scalability and just general robustness of applications using MongoDB.
It really is. These aren't just sort of theoretical tweaks. They directly translate into MongoDB deployments that are more resilient, higher performing. Which brings us to the key question for you listening right now. Are you actually leveraging these advancements? We'd really encourage you, if you haven't already, dig into the MongoDB 8.0 documentation. Start testing these features in a staging environment, getting ahead of the curve, adopting these improvements early. It's not just about avoiding surprises when you eventually upgrade. It's about making sure your systems stay robust, stay performant, especially as your data and traffic inevitably grow. All right, folks, that's it for today. Thanks for joining us for another deep dive.
Thanks for having me.
Until next time.
See you later.